Right. I think we will continue this problem. I have given you a case. I think I'll just give you the essence of the problem. What is that problem? See, there is a regular hexagon and a body is projected from this side. Now, if this body grazes past 1, 2, 3, 4 vertices of this regular hexagon, what is the range of this projectile? This is the question. Now, whenever such questions are asked where the data is very vague, very vague, abstract, in such cases, you take resort to the equation that we have developed there. As I told you, y is equal to x tan theta into 1 minus x by r. Now, I can write for one coordinate and second. First of all, in this path, the trajectory, I have chosen one coordinate because this x is what I have assumed. I do not know what is that x. If I find out x, I get automatically the range. So I've got x comma d root 3 by 2, and this is x plus d by 2, and then this is d root 3 by 2. This is another d root 3 by 2. Total is d root 3. Alright? Now, I simply substitute these equations. Remember, we wrote here 1 minus x by r. Now, x here is x plus d by 2. Therefore, here also it should be not x plus d by 2r. Now, the question is, it is only a kind of mathematical jugglery to get the answer. Now, all this is not required for you. This is also not required for you. Now, or of course is given that. Now, if you divide these two expressions, likewise, one advantage is that tan theta gets cancelled, d root 3 gets cancelled. So 1 by 2 is equal to x into, I can write this as r minus x by r, and this is x plus d by 2 into r minus x minus d by 2 by r. This r also gets cancelled. Alright? Now you have an equation where the variable r and x are related. So what we do here, easy method I am telling you, you have x plus d is equal to r by 2, or x is equal to r by 2 minus d, or r minus 2d by 2. Right? Now you have got x value, that is what you have to substitute in all these cases. So you cross multiply, take 2 onto this side and bring everything onto this side. X plus d by 2, r minus x minus d by 2 is equal to 2x into r minus 6. Alright? Now I would expect you to substitute, say instead of x, you substitute r by 2 minus d. Here also r by 2 minus d. If I substitute r by 2 minus d, you have already got plus d by 2, and here r minus, what is x? Minus r by 2, minus of minus plus, isn't it? R as it is, minus x, minus r by 2 plus minus r by 2 plus d. And this says minus d by 2. And on this side you have 2 into x is r by 2 minus d, and r minus x. I am writing it all likewise. So this is what is given. Now you can rearrange the terms this side, and I finally you get r is equal to d root 7. Let me not unnecessarily waste time to get this, because you simplify and get r square is equal to 7d square, or r is equal to d root 7. I hope this is clear to you, right? Now, as I have told you, in the projectile cases, first we saw a triangle. Within that, then we saw how there's a regular hexagon part, and now if you see, there is another way. Say, for example, again I am confining my attention only to symmetric projectile. So you have, suppose the projectile just clears two walls of same height. Just clears means like this, almost touching, separated by a distance d, and this is h. Likewise, the problems could be given. You see, now if this is the case, they may ask you what is how to go about when such problems are given to you. Now that is important for you. For example, a body is projected with u. Let this angle be d theta. Okay. Now let this body clear these two walls in times t1 and t2. Now be very careful about this point. What exactly does he mean by T1 and T2? Now, for example, the projectile crosses the two walls of equal height, say in 3 seconds and 6 seconds. That means first 0 to 3 it will clear one wall, 0 to 6 it will clear another wall. Sometimes they may ask the question, the same question, for example. It will clear the wall in 3 seconds and clear another wall in another 3 seconds. So that also amounts to 0 and 3 and 6 only. I hope this is clear to you. I'll clearly write down here. So from here till here, T1. From here till here, it is T2 seconds. And by symmetry, we know that this is nothing but T1. So, what is the time of flight from this? T is nothing but T1 plus T2. That's a very important thing. And with this theta, time of flight, you know for symmetric projectile, it is nothing but 2u sine theta by g. And in what time this crosses these two walls? So total T2 minus T1. In this, what is the velocity? What is the velocity? U cos theta. What is the displacement in the horizontal? D. Therefore, it is d by u cos theta. Now, these two are given. So, from this you can find out what is u sin theta and what is your u cos theta. Is this clear to you? Now, how do you get that? U sin theta is half g into t1 plus t2, and u cos theta is d by once T1, T2 and D are given, I think you can work out everything and find out what is H also. Because U is known, theta is known, then directly you can say this is your. For example, range he is asking. What is the range? U cos theta into time of flight. What is time of flight? Here T, sorry. T1 plus T2. Okay? And what is u cos theta? D T1 plus T2 by, sorry, this is T2 minus T1. Okay? So you have T2 minus. Directly you can give the range for this. I hope this is clear to you now. Okay? So they may ask several such questions based on that projectile symmetric. We have seen, if you recall, a number of cases in the symmetric projectile. Okay? So they can give, for example, you see, x is equal to, say, 10t, y is equal to 20t minus 5t square. Something like that they may give. So they may ask anything, but you simply compare with your original equations. X is u cos theta t, and this is u sin theta t minus of gt. If you compare, what do you get? U cos theta is equal to 10, u sin theta is equal to 20, g by 2 is equal to 5. Now as before, you got u cos theta with u sin theta with g value. You understand? Sometimes to confuse you, it's not necessary that every time it should be 5. It can be on any planet. Suddenly they may say it is only 2 square. So what does it convey? G by 2 is equal to 2 implies g is equal to 4. Remember, in all these cases, what you should try to do is to obtain u cos theta, obtain u sin theta, and obtain g. So anything and everything you will get very easily. Is that clear to you? Okay. Now look at this. Y is equal to ax minus bx square. Suppose they have given. This is a general expression for our projectile. In this, what is A? Tan theta. What is B? 2 u square. Any idea? I'll write here for you. Y is equal to x tan theta minus gx square by 2u square cos square theta. So you have to compare and write A is equal to tan theta, B is equal to. But cos square is 1 plus tan square. But tan is A, therefore G is equal to, this is your B. So by analogy and comparison, they may ask any problem. You can easily find out this, there is no issue at all. Like they may give analogy by giving X form, or as I have given you in the previous case, X is equal to 10t and y is equal to, say, 20t minus 5t square or 2t square. Likewise, you go on writing it. I am sure you will get those problems. I think most of the problems that are based on this, you can easily find. But one good thing here is, h is equal to u square sin square theta by 2g, r is equal to u square 2 sin theta cos theta by g. Suppose I take h by r. What do you get for h by r? This is tan theta by 4. Now this is very important here. For any symmetric projectile, actually tan theta takes any value from 0 to infinity. Therefore, this can be greater than or equal to or less than 1. What do you mean by that? H can be greater than R, equal to R, less than R. There is no hard and fast rule that, see, there could be projectiles which go up like this where H is much more compared to R. There are projectiles which will go like this, in which case this is much less compared to the range. Now, here is an interesting case where H is equal to R. What do you mean by H is equal to R? What do you get? H is equal to R implies tan theta is equal to 4. If tan theta is 4 or 4 by 1, sin theta is 4 by under root of, every time some tan theta is given, how to write sin and cos you should know. So cos theta is 1 by root of 4 square. Opposite side, adjacent side. This is hypotenuse. This is hypotenuse. So this is adjacent side. This is opposite side. Alright. Now they may ask, suppose I want to write H is equal to u square sin square theta by 2g. Right. Now what is sin theta? Sin theta. Sin square theta, u square by 2g. 16 by 70. So this is, so what do you get? So they may ask like this, and whether it is H or both are one and the same, you substitute, you are good. See, they may give you problems of this nature which is not very difficult for you to follow because they are based on these simple formulations. Alright? Okay. Now, you see, one more thing I want to give you. R is R max. We have already seen that when theta equal to 45 degrees. This is what you saw. I'll just put it here for you. You said, now this is your original u. This is your v. Being symmetric, mod u and mod v are bound to be one and the same. Now, likewise, okay? You know that this is theta, this is theta. So obviously the total angle is 2 theta. And we have just said theta 45 means 2 theta must be 90 degrees. Okay? And since these two are one and the same, this will be 45 degrees and 45, this is 45, this is 45. Likewise. I hope this is clear. Now, in any case, whenever you get range to be maximum, you should in fact always have the angle between these two vectors must be 90. Then only you will have the maximum possible range. Okay? Now, presuming these two are not one and the same. I take u to be something, maybe u like this, so something like this. Still this is 90 degrees. This may not be theta, this may not be theta, but the point I am discussing is very important. Initial velocity vector and the final velocity vector at the landfall, both must be perpendicular to each other. U bar must be perpendicular to V bar at the point of landfall, and then you will have maximum range. It's a very important case for you, and I will definitely discuss this point But you keep this in mind that this angle must be exactly perpendicular 90 degrees, okay? Now, so we have seen a few cases in the case of oblique symmetric projectile. We have seen some of the complicated things also. Now we will go a little deep into it. Say for example, I am taking a case where I am projecting a body like this with you. At an angle, theta, let this be h. This is what? Now I deviate from oblique projectile from top of a tower. I had an inclined but upward projection. Now, if I take this as I, this as j, as before, you can write your equations as u cos theta plus j u sin theta. A, no change, no E bar, no change. All right? Yeah. V bar, no change. S bar, as before, Ix plus Jy, but X is u cos theta t, and Y is u. Every time a problem is given, you should be in a position to write all these things automatically. U square sin square theta, now plus 2 minus g. Be careful, plus or minus y I kept. Why? If it is above the point of projection, I put y positive. If it is below the point of projection, I put y negative. Alright? So once you write this, you will get it. Now, if I ask you what is the time of flight for this? Now recall, I gave you one universal formula for time of flight. From here also you can get this. In the previous case, symmetric projectile, we have equated that with 0, but now you equate that with minus h, because at the point of landfall, the displacement is minus h. So it is again a quadratic equation, and once you substitute in that, I have just given you all this, you get the expression for time of flight. Okay? Now, but without all this, I told you, what is the vertical component initial? U sin theta. So, velocity by acceleration whole square plus 2h by g. It is upward, therefore, plus opposite. U sin theta, g are opposite. This is important. I told you, even in two-dimensional flow, you can still write your, use your universal expression for time of flight. Suppose I want to get what is the range. The range is equal to, what is the range here? U cos theta into t, this t you have to keep it here. Now it becomes a very complicated expression. Very, very complicated expression. Remember. Now, I want you to understand that if I want to get R max, you know, the way is generally take this, get the first derivative, put it equal to 0, that becomes too clumsy a process. This is not required for you. Now, as I told you, if you take at the point of landfall, that is u, okay, obviously this is theta because you have projected with theta. Now this is much more. Why much more? This is coming below the point of projection. So this is your final modulus. This is initial modulus of the velocity. Now this being a 90, obviously how much should this be? 90 minus theta. Got it? This is 90 minus theta. Now, if somebody would ask you, as we have done in the previous case, you got tan, at what angle you should project? The tan theta must be such that tan theta should be equal to mod u by mod v. Got it? And what is mod v? Now look at the last expression in that mod v. Mod v is equal to your y is minus h. So if you put minus h, what do you get? I'll just write down that expression for you here. Is equal to iu cos theta plus j into root of plus 2 minus g minus g minus h becomes plus. So what is the modulus of all? U square cos square theta plus u square sin square theta plus 2gh. This becomes u square. So you can write that as under root of u square plus 2gh. U square plus 2gh. Okay? Now I will erase this part and write at what angle should you project? It should be u by under root of u square plus 2gh. Another very important point. Now range, if you want to get, there is no derivation as such anywhere here, but you can always write range as u bar cross v bar by g. You understand this? U cross v. Now let us put it for our original case, maximum range. This is your range expression. So how do you write that range expression wherever you want it? Now if I want to get R max, what do you mean by R max? Here the angle between them must be equal to pi by 2. So that this, what is the maximum value? R max is mod u mod v by g. Mod u mod v by g. Now is it yeah, is this clear to you now what I am trying to put? Now let us go back to the original expression. What was your range expression? U square sin 2 theta by g. Alright. Now this is u and this is your v. What is the angle between these two? 2 theta. Any projectile you take, oblique projectile you take, you are going to get like this. Therefore, it is u square sin 2 theta by g. That is your general expression. I hope this is clear now. There is no derivation for this, so do not try to expect any such thing, but it's something that I'm going to make use of. Things become very, very easy for you to work on. Okay? Now, let us look at this. We have already done what is the tan theta value, and remember my max, R max is mod u mod v. What is R max in this case? U mod v is u square plus 2gh by g. This is a very, very important expression for you. I have tried to derive it with the vector product. It becomes fairly simple, that is why. Therefore, these two, if I want to take tower height to be 0, suppose. Tower at 0 means what do you get for this? It becomes u square by g. This becomes 1, that is your original symmetric projectile. Why I am talking about this at such a length is for this reason. So, hereafter, every time you want to get range, take like this, where g is the acceleration. So, mod u cross mod v by g. So, you get range. Now, what is R max? R max is mod u mod v by g. And what is the angle at which you should project? Mod u by mod v. This is the thing. Please memorize this. Wherever you want, you can use it. Now look at this. My question to you now based on this. Suppose you are throwing a shot put or a javelin. Say you run and from such point you throw it. Can you tell me at what angle should you project such that it has maximum possible horizontal range? So what do you do? Generally, people say because he is projecting it from the ground, you say it should be projected at 45 degrees. It is wrong. Why it is wrong? Because you are projecting it from the shoulder height. So the ground is at least 5 to 6 feet below the point of projection. So this is nothing but javelin throw, shot put, or nothing but cases of oblique projectile from the top of a tower. Therefore, what angle should you project? This is the angle at which you should project. And you know that this is always less than 1. So, theta must be less than 45 degrees. Very, very important. And then, what is the maximum range? It is u into under root of u square plus 2gh by g. This is how you will get. Where, in which case am I talking about all this? From the top of a tower oblique projectile. So you have seen two things in this. I'll put it again for your information. First is your time of flight. Time of flight, I write it again for you. We use the same formulation with which we have got virtually every possible time of flight formula. And then the range, of course, is u cos theta t or u bar cross v bar by g. And when you go for R max, it is mod u mod v by g, and theta must be tan inverse mod u by mod v. But what is mod v? I have already told you. Final velocity when it is about to touch the point of landfall. is nothing but u square plus 2gh, which you can substitute here and here. So this is what I have tried to tell you in the oblique projectile from the top of a tower. Okay? Now, let us now go to horizontal projectile from the top of a tower. For example, what do you mean by that? Look at this. I am projecting it with you. So this is likely to reach. Let this be height h. Now be careful. I am taking it as I am taking downward as j. It is convenient for me, that's all. There is no hard and fast rule. But every time if a g is downward, I'll take j also downward. Everything is downward in this. And then how do I write as we used to do? Sorry. What is u bar? The entire u is along I, and therefore I write it j, there is nothing, so for your information I am putting it to be 0. Okay? Now, what about a? G is how it's directed? Downward. J, downward. Along I, 0. So j, g plus jg. Previous cases I took j upwards, therefore I got it as minus jg. As you know, once you write u and a, all other terms can be written. V, no acceleration and no initial velocity. S bar, ix plus jy. What is ix? X is ut, j is object is there because no initial velocity. And finally, vxy iu plus j root 2gy because initial velocity 0. You see, so easy to write these equations once you establish these two. Alright? Now, look at that. If I want to get what is the time of flight? What is the time of flight means? What do you do? Here, same tower, previous case, oblique, therefore theta. No oblique, therefore theta is 0. So, theta 0 means what do you get? I write it for you here. U sin theta by g whole square plus 2h by g plus 0. So the time of flight in the case of a horizontal projectile is under root 2h by g. Now this I'll explain it to you in a pictorial form. For example, I am projecting it like this, so it will come here. I may project it with more value, it may go there, or still more value, it may go there. But remember, t is same for all these cases. T is same for all these cases.